Namaste, this is JV and Dr. Vishal Saxena, Associate Professor in Mathematics in Jayoti Vidyapeeth, Women's University, Jaipur. Today I am going to discuss on the module T-Test. This T-Test, this module is a part of the course Biostatistics and under the program of MSc NND, MSc Microbiology, MSc Biotechnology and MSc FST first semester of the university. As this T-Test is similar to the other statistical tests like the ANOVA test and the chi-square distribution test and normal distribution test, because it is very useful test, and by this we can just determine whether the two data sets are significantly different or not, and it is important for the just finding of the difference between the two samples and their means, and that's why it is also a part of the various courses of the university and the other universities as well. It is also a part of the research methodology which just deals with the part of the testing of hypothesis and statistical tests for the different results for the different data sets, and important for the higher studies and the research purpose. So T distribution test is an important part of that subject also, and this T distribution test, T-Test, is based on the T distribution, and it can be defined as just like it is the test which can be used to determine whether the two data sets are significantly different or not. So in this test, the test can be divided into three parts, means having the three components. One is the independent T-Test, second is the single T-Test, and the third is the paired T-Test. All the three tests, T distribution tests are very important for the different purposes. So the first test of the T distribution test is the independent T-Test, and we can apply the this independent T-Test to determine for the finding of whether the means, the two population means are significantly different or not, means the difference for the means of two different populations, while the one sample T-Test can be used to differentiate, to check the difference, the significant difference between the population or the one sample, between the sample mean with the like theoretical mean or the expected mean or the hypothesized mean. So that can be very important application part of one sample T-Test. While the third test for the T distribution test, that is called the paired T-Test, and that gives a hypothesis examination of the difference between the population means for a set of random samples whose variations are almost normally distributed. So it means this test can be used to examination the difference between the population means for a set of random samples. So these are the three parts of the T distribution test, and very important test. This can be this can be taken as for the statistical hypothesis testing. And in the today's session we are taking with mathematical concept and how to apply these tests. We will see that. Today we are going to share some slides for the concept of the t distribution and its application parts. So in the initial slide, the t-test definition is given that like it can be used to determine if the two sets of data are significantly different from each other. So it means just this test means the t-distribution test can be used to find out if the two data sets are significantly different from each other or not. And the t-test uses the means and the standard deviations of the two samples to make a comparison. So it means the t-test, the t-distribution test uses the mean and the standard deviation concept of the two samples for their comparison. Now here we are having that the statistic t statistics is used to just differentiate between the two data sets, and the t statistic is given by x1 bar minus x2 bar upon s del bar, where s del bar is given that s1 square upon n1 plus s2 square upon n2 and with under root. So what are the notations for these formulas here? X bar always represents the mean of the set, so x1 bar is the mean for the first data set and x2 bar is the mean for the second data set. S1 and S2 are the standard deviations for the first and the second data sets respectively, while the N1 and N2 are the size of the two data sets. So these are the notations, and one important thing is there, that is the standard deviation that can be obtained as by the formula of under root summation of x minus x bar whole square upon n minus 1. Now we are having the first component of this t distribution test. The t distribution test, just we have already explained that it can be used to find examine the that there is a significant difference between the two means in the two unrelated group or not. So this t distribution test is a test which determines that whether there is a significant difference between the two means in the two unrelated groups or not. And this independent t-test is also known as the two sample t-test and or the independent samples t-test or the students t-test. In this test we will assume that the hypothesis, null hypothesis, as the population means from the two unrelated groups are equal, means u1 is equal to u2, that is h0. So that is the null hypothesis, means we will assume that the population means from the two unrelated groups are equal. While in the alternative hypothesis we will assume definitely it's a reverse part, that means the two population means are not equal. So that is the alternative hypothesis which is written by HA. Now next, what do you need to run the independent t-test? So what are the points to run the independent t-test? That the first point, one independent categorical variable that has the two labels or the groups. So it means we need the one independent categorical variable and having the two labels or the groups. Second point, one continuous dependent variable. Now next is the one sample t-test. The one sample t-test is again an important part for this t-distribution test, and this can be used to compare the mean of a population to a specified theoretical mean. So what is its main purpose? That can be used to compare the mean of a population with a specified theoretical mean. That is the main purpose. So the one sample t-test determines whether the sample mean is statistically different from the known, that means the hypothesized population mean. So that is the main objective of this one sample t-test. And what are the uses of this test? Statistically difference between a sample mean and the known or the hypothesized value of the mean in the population. Then second point, the second use is statistically difference between the sample mean and the sample midpoint of the test variable. So that is again an important use for this one sample t-test, that we can just find the difference between the sample mean and the sample midpoint of the test variable. The hypotheses are formally defined below. What are the assumptions we have to take here? The null hypothesis assumes that the difference between the true mean and the comparison value m0 is equal to 0. Just we will assume that in the null hypothesis that the true mean and the comparison value must be equal to 0, and therefore the alternative hypothesis will be the hypothesis which consists of its reverse statement that these two are not, means the difference between these two must be not equal to 0. And now we can use the upper tail t-test or the lower tail t-test for testing the hypothesis. Means the upper tail or the lower tailed t-test can be used for this. Next, the one sample t-test has the four main assumptions. So what are the four main assumptions for this one sample t-test? The dependent variable must be continuous. The observations are independent to one another, and the dependent variable should be approximately normally distributed, and the dependent variable should not contain any outliers. So these are the four important points, that the dependent variable must be continuous, and the observations are independent to each other. The dependent variable should be approximately normally distributed, and the last point of this, the dependent variable should not contain any outliers. Now next, the paired t-test. The paired t-test again is a third and important component of the third important test of the this t-distribution test, and this test can be used for the paired t-test gives a hypothesis examination of the difference between the population means for a set of random samples whose variations are almost normally distributed. So this test can examine the difference between the population means for a set of random samples and whose variations are almost normally distributed. So the paired t-test is a test that the differences between the observations are 0. So now to just run this test, what should be done here? Suppose that we are having the two paired sets, one is xi and one is yi, and I from 1 to n we are having the data. So xi and yi are the two paired sets. Next, then the paired t-test concludes whether they are notably vary from each other. The paired sample t-test, sometimes called the dependent sample t-test, is a statistical procedure used to determine whether the mean difference between the sets of observations is 0. So what is main its purpose? That just we can check here the mean difference between the two sets of observations is 0. And in a paired sample t-test, each subject or the entity is measured twice and resulting in pairs of observations. Common applications of the paired sample t-test include case control studies or the repeated measure designs. So these are the important application part where just we can use this in the case control studies or the repeated measure designs. Now paired t-test formula. So how can we just apply the paired t-test? Paired t-test is a test which is based on the differences between the values of a single pair, that is one deducted from the other, like xi minus yi. In the formula for a paired t-test, the difference is noted as d, and now we can see this t which is called the t statistic is given by summation of d upon under root n summation d square minus summation d whole square upon n minus 1. So that is the formula for the t statistic to apply. Next, the characteristics of paired t-test. So what are the characteristics for the paired t-test? The data is taken from subjects who have been measured twice. 95% confidence interval is obtained from the difference between the two sets of joint observations. And how to find the paired t-test? First of all, we are having the two data sets xi and yi. So like xi is the first element of x and yi is the element of y, general element. So we have to find the difference di for every xi and yi. So di is equal to yi minus xi, and then we have to find the mean difference, calculate the standard error of the mean difference, and it is given by as d upon under root n, and n is showing the total number, as d is showing the standard deviation of the difference. Then we have to find the t statistic value, and next in the next point and in the last point the t distribution table will be used to compare the t statistic value which is obtained here with the t n minus 1 distribution. So refer to the t distribution table and compare it with the t n minus 1 distribution, and it gives the p value. So in this way the t distribution test or the p distribution test can be applied. So this is again a very important part, paired t distribution test, in which the set of the values can be compared. That means the population means for the different sets can be compared, and this is again an important part of the t distribution test. So in the today's session we have taken all the part of the t distribution test, and the students are advised to take objective as well as the descriptive questions with numerical questions for this session. With this I conclude my today's session. Thank you.